Hello everyone. Today I will present the final project of the control system project informations. The control circuit is a circuit used to change the voltage direct current from a current source where there is a certain level of pressure taking it to another level. Most of its implementations will change the pressures to play to the measures of the DC motor to assist in starting and controlling the speed of the motor, and it can also be used as a DC power supply that changes the voltage easily. This picture show the working block diagram of the DC motor controls. Chopper type DC electric motor drive in the two quadrants. Direct current drive in the second quadrant cause the motor to stop rotating or break. The motor regeneratively is the positive, but the direction of the current is the reverse. The direction from the current direction is negative. In this condition, the motor changes to a generator. The motor power is reversed to the power supply and is reduced through the DC circuit. By the IGBT, the torque has an opposite direction to the original mechanism directions, causing the speed of the motor to decrease rapidly. Next, transfer equations of open-loop DC electric motor. A DC motor speed will change depending on the type of load, maintaining a constant speed. The measured voltage is continually adjusted by the angle from the AC-DC converter or the duty cycle of the DC chopper. In the practice, the control is very popular in industrial motor drives. It uses closed control cycle, the closed circuit control. The closed circuit control system is effective in adjusting in precision the response in fast and the signal interference in is reduced and the system is stable. This open loop transfer function of DC is giving as V multiply S divide UA equal 10 divide 1 plus 10 multiply S, and this body diagram of open loop transfer function of DC motor. Next, I show the program, and this code that all for the DC of the motor, and sections 1, and this I try write of transfer function of the DC motor and transform to transfer functions section 1, and this time, and I define in time and shifting time, and this frequency I use frequency 500, and define equation of the frequency and the phi and their author, and this different trajectory. I define equation of the different trajectory equal 200 multiply square and multiply to multiply pi divide 0.03 and multiply 3. Next, I use a method to recommend the formula. I define j equal and minus 80 and minus 80, and I use an initial condition of the method tree anchorman formula, and this for loop of formula, and I did next and use a set transform of array input, and I use intermetwork.com. I use this formula in websites set domains, and this state space functions, and the system continue time state space model and stability pro and pro placements, and these sections. And next in the section of the plot graph method, and the figure 1 and this graph 3 graph x1 x2 and u voltage graphs, and the figure 2 is a result of the frequency domain of a DC motor, and I zoom out of the graph. Zoom out. Okay, graph is an appear of a frequency domain, and zoom in. Okay, next is the figure 3 and the result of the time domain of a DC motor, and this graph is the results, and the last figure 4 and this loose locus of the speed of a DC motor is results. Next control system designers. I use edit architecture and import block name 3, and import base workspace of the project control of code in MATLAB, and after run I use this G1 GK G4 GF stem, and then click import. Okay, when I click import it's okay, and wait a minute. When click import, graph is appear this body editor of loop transfer, and loose locus editor of loop transfer function, and IO transfer to Y, IO transfer to Y, this the body diagram, and uh, of a magnitude and phase. And this body diagram du2y, and this open loop Nicole editor for loop transfers. And that's all for my projects. Thank you for watching. Bye bye.